the track shown in figure is frictionless, the block B of mass 2m is lying at rest, the block A of mass m is pushed along the track with some speed, the collision between A and B is perfectly elastic, with what velocity should the block A be started to get the sleeping man awakened? So, let us assume that this block A is given a velocity of u1 initially, and when it reaches here B, then before collision it has a velocity of v1. So initial velocity of VA is u1, while the velocity of A block just before collision is v1. Now I can write it as, from the energy conservation, that half m v1 square minus half m u1 square equals to mgh, giving me the value of v1 to be under root 2gh plus u1 square. Let us mark it as equation number 1. Now, when this block B hits this man, then the minimum velocity possible is 0. That is, it will be just greater than 0. So I can take this V to be 0. Now this block, for this block, let me employ the energy conservation. So that will be the final kinetic energy being 0 minus initial kinetic energy being 2m into v square, where v is the initial velocity, that is just after the collision velocity of block B, equals to mgh. This gives me the velocity v to be under root 2gh. Now, since this has been given that it is an elastic collision, so let us first employ the momentum conservation before and after the collision. Before, it will be mv1 plus 2m into 0 equals to, afterwards we will be having m into v. This v and this v are different, so let me mark it as vb. So this will be m into v plus 2m into vb, which is 2gh, giving me an equation of v1 minus v to be twice of under root 2gh. Also, from the energy conservation, I can write down half m v1 square plus half 2m into 0 square is equals to half mv square plus half into 2m into root 2gh whole square, because total kinetic energy is same before and after the collision in perfectly elastic collision. So this gives me the equation v1 square minus v square to be twice of under root 2gh under root 2gh. Now divide equation 1 and 2 in order to get one more linear equation, that is v1 plus v to be under root of twice gh. Now we have this equation and this equation, from which we can calculate the value of v1 to be 3 by 2 under root 2gh. Now put this value of v1 into equation number 1 in order to get the value of u, or that is u1, that is under root 2.5 gh. So we did, in this question, we found out the velocity of A before the collision, that is here. Then we found out the velocity of B after the collision, with which we found out the momentum conservation, giving us the relation between v1 and v. Again we found out one more relation between v1 and v in order to get the value of velocity of A before collision, and then we equated both the values to get the initial velocity or u. So this is the velocity that must be given in order to have the velocity of B to be 0 here when it hits the man. So the velocity can be u or greater than this, depending upon you with how much velocity you want to hit this person. But this is the minimum that you need.